All right. Good morning, everyone. We're going to go over these three questions. You may have had time to do them, or if you just joined us, you didn't get time to do that yet. But I want to make sure we have all the time we can have to get through the lesson today. So I'm going to go through these pretty quick. But the idea here with the first problem is it is a right isosceles triangle, which means both of the base angles are the same and that means they're 45, 45, 90. So this is one of our special right triangles. The first thing I'm going to do is take my formulas and place them around the triangle in the right spot. So I get cross from both the ends, those are the same, so it's n, and then n squared root of 2. Now the algebra that I have to solve or use is to solve for n. So I'm going to take and divide by the square root of 2 to both sides. It's going to reduce the n here. But we run into a small problem. I have the square root of 2 in the denominator, and we don't like that. So we're going to times the top and the bottom by the square root of 2. That's called rationalizing the denominator. And then remember, this turns into the square root of 4, but the square root of 4 is 2. So then I have my whole numbers. 12 divided by 2 is 6, and that gives me n being 6 square roots of 2. So the two missing sides are 6 square roots of 2. Now, if you notice the directions, we wanted to find the missing sides, but we also wanted to find the missing angles. Today, we're going to call that solving the right triangle, where you know all three angles and all three sides. And that's the goal for each one of these problems. All right, so number one was 45, 45, 90. Number two is not one of our special right triangles. In this case, they give us a reference angle of 54 degrees. And it doesn't matter to me which side you find first. I'm going to call this side x. Let's find x first. So now I notice, where is the position of x? It is in the opposite side, and the given side, 10, is the adjacent leg. So I have opposite and adjacent. Well, I'm going to think SOHCAHTOA. Now notice, why did I know I had to use SOHCAHTOA? Because it wasn't a 45, 45, 90, and this isn't a 30, 60, 90. There's no way these could be 30 or 60, so I have to use SOHCAHTOA then. And I have the opposite and the adjacent, and the only trig ratio that has both the opposite and the adjacent in it is tangent. So I'm going to take the tangent of the reference angle is equal to the ratio of opposite over adjacent. And some students like to write opposite over adjacent so they can see where this tangent ratio comes from. And then remember, think of that as a 1. And now we're going to cross multiply. So we're just going to take 10 times the tangent of 54 degrees has to equal 1 times x, or just x, and then we're going to round to the third decimal. Please make sure that you are double checking. If you grabbed a new calculator, you are in degrees mode, but you should get 13.764. We rounded the third decimal up to from a 3 to a 4. Now, I always like to put this information back into my picture. I know the side length x, but I'm not done because I want to find all three sides and all three angles. Well, now I have two sides of a right triangle. You could, let's call this y. We could use Pythagorean theorem if I wanted to find y. That's acceptable. Or, what spot is the y in? Well, the y is in the hypotenuse side because it's across from the 90. So in that case, you could use opposite over hypotenuse, which is sine, or you could use adjacent over hypotenuse, which is cosine. I'm going to choose to use cosine, and the reason why is I like to take the friendlier number, but I like to take the number that they gave me in case for some reason I made a small error here. But I want to do cosine of 54 degrees. So cosine of the reference angle is the adjacent over the hypotenuse, A over H. That's the cut, right? So we get 10 over Y. And notice it's basically the same setup we have here, except for the Y and the X were in different positions. So I'm going to cross multiply. That we did see the other day, though, you can actually switch the position of the Y in the cosine. That's kind of a way to cheat, but a faster way of doing it. So Y divided by 1 is Y. And then I'm just going to take in my calculator right here. I'm going to do 10 divided by the cosine of 54 degrees. It's 17.013. In this case, we didn't really have to round to the nearest third decimal, but I now know the hypotenuse side as well. All right, so we're almost done. The directions said find all three sides. We did that. And now we have to find all three angles. Well, if you know two sides of a right triangle, or excuse me, two angles of a right triangle, you can add the other two sides up and get the sum of the other side by subtracting from 180. So 90 plus 54, or if you have 180 minus 90, that means there's 90 left. These two acute angles will always have to add up to 90, which means this missing angle is 36. All right, so that was SOHCAHTOA. Now again, we call this solving the right triangle. So you found all missing sides and all missing angles. We're going to do the same thing here with number 3. The only difference is this is a very special number, 60 degrees. So if that's 60 and this is 90, this has to be 30. So I've got 30, 60, 90, and I'm going to grab my formula marker, and I always place the smallest side first. Okay? So we're going to put our formulas. Across from the 30 is the smallest side of n. Across from the 90 is the largest side of 2n, and that leaves the middle side being across from the 60, so n squared of 3. All right, well, that leaves just a real quick algebra problem right here. 16 equals 2n, which means n would have to be 8. And that tells us the short side is 8. And then across from the 60 degrees is 8 square roots of 3. Now, I do want to mention one thing really quick, and it's just something that you guys should be aware of. When we give you a 30, 60, 90, we're expecting that you're using the formulas because that's the fastest way to do these problems, right? Or if I give you a 45, 45, 90, we're expecting you to use the shortcut, the special right triangle formulas. However, you could also use SOHCAHTOA for these problems as well. The only difference is your answers are not going to be nice, friendly, radical answers. So look at the difference between the answers in number 3 and number 1 versus the answers in number 2. All right, so there's a benefit. Number 2, we had to round. Number 3, we don't have to round. Number 1, we didn't have to round. So really, the answers to number 1 and number 3 are more accurate than the answers to number 2, because in number 2, we have to round. So what's left in trimester 1 of accelerated geometry? So today we are right here. We're doing section 7.7. It's the last new learning of this trimester. On Wednesday, we're going to do a Unit 5 review in Delta Math. And you should also turn in all your late work, including missing assignments, if you didn't do the Unit 3 project yet, or if you didn't take a test yet, get that stuff done right now. And then if you want to do test corrections for 70% back, I'm going to say all those have to be due by Wednesday. You should have been working on that over the weekend. On Friday or Thursday, I'll see you on Thursday, we're going to have a in-class Kahoot review. And then the homework that night will be to finish the review and then work on any missing pieces as well. And then our test is going to be, for you guys, it'll be on the 24th, Tuesday, and it's our Unit 5 piece. All right, and that's it for the trimester. It's almost done. Okay, so we are starting today something called solving right triangles. Now I'll give you a hint. You did that 3 times already in the warm-up. When we say solve a right triangle, you need to find all 3 sides and all 3 angles using whatever method you can use. Special right triangles, Pythagorean theorem, SOHCAHTOA. This officially, when we say solving right triangles, we just are answering the question, how do I find all the sides and angle measures of a triangle? And officially, this is section 7.7. Okay, just another plug or another reminder. Cornell Notes is a great way to study. We're not going to check those or requiring them, but we are encouraging you to go back through and interact with your notes on a nightly basis. That's the best way to study for math. That and do homework consistently. All right, so we're going to jump kind of right into it here. Do not write this slide. Okay, this slide is just a quick review. But a reminder, we learned SOHCAHTOA, right? What is SOHCAHTOA? Or another way to think of it is, what does trigonometry help us actually find? Well, trigonometry helps us find side length. If we are given one side and one acute angle of a right triangle, SOHCAHTOA allows us to find a missing side length. And that's what we did in the warm-up. That's what we did the last couple days here. So again, don't write this. But remember, what is SOHCAHTOA? If you had some questions, I really hope that somewhere written in your notebook, really large, is SOHCAHTOA. And then how do we use SOHCAHTOA? SOHCAHTOA is just basically setting up ratios. So if I want to do the sine, all right, well, sine is opposite over hypotenuse. And then notice, right here, it's sine of something. That something is always the angle. So across from angle B is always the opposite. What makes up angle B is the adjacent side and the hypotenuse. So if we know what the 3 sides are, then the ratios of sine is just the opposite, which if I don't have a number, I can just say it's the length AC. And it's over the hypotenuse, which is the length BC. And that's as far as I could go with this problem because we don't have any other context. Now what about cosine? Well, cosine is the or the adjacent over the hypotenuse, A over H. So the length of the adjacent is AB, the length of the hypotenuse is BC, and that's as far as we could go for that problem. All right, and then tangent. What is tangent? Tangent is TOA. That's the opposite over the adjacent. So we would say the length of AC over the length of AB. So that's where we came from, right? That helps us find the missing sides, but we would have to know the angle. Right? The only way we could do these problems right now is if I knew the measure of the reference angle B. Well, today the question is, what if we don't know the angle? What if we know we have a right triangle, but we only know 2 sides? So those are the 2 things. I would write this slide here. Right? So what if we have a right triangle but only know 2 side lengths? Well, if I know 2 side lengths of a right triangle, could you find the third one? Hopefully the answer is yes. Pythagorean theorem, right? You can always find the third side length of a right triangle if you know 2 sides, and that's where Pythagorean theorem came into play. Can we find missing angles though? Right? What are the other 2 angles if we know it's a right triangle and we have 2 sides? Well, that's where this new concept today comes into play. And it's called trig, called inverse trig, right? So inverse of trigonometric ratios. Let's think about that word inverse quick. What is an inverse? An inverse will undo the original function. You learned inverses way back when you first started learning math, right? You learned adding, and then its inverse was subtraction. And eventually you learned multiplying, and the inverse of multiplying is division. Then you learned how to square things. Right? Squaring, the inverse of squaring is square rooting. Well, functions have inverses, and sine, cosine, and tangent are functions. Right? It's a behavior that we can model. So our question then is, if I take the tangent of angle A, or the sine of angle A, or the cosine of angle A, that's applying a special math relationship to angle A that gave us the ratio. So we're basically going to set up exactly what we did before. And I'm going to still think, all right, this is written in a little different order, but so, and then TOA would be up here for tangent. So how do we approach a problem like this? The nice thing is it's only one extra step today. So what we're going to do is, if I want to find the measure of angle A, I actually have three options. I could do tangent, sine, or cosine, but it depends on what the side lengths are. And in this case, we don't have any side lengths yet, so we're just going to give you the ratios. So how do we approach this? First, I have to figure out the angle I want to know is angle A. So then I have to just identify what is the opposite of A, what is the hypotenuse, and what is the adjacent for A. So just like we did before. And then we're going to set up those ratios. So what was tangent? Well, that's TOA. Tangent is the opposite side. In this picture, it's BC. And the adjacent side is AC. So you can see why I didn't want you to write the other slide, is we're doing the same thing here. And then let's set up the ratio for sine and cosine. Sine is opposite over hypotenuse. So BC over AB. And cosine is adjacent over hypotenuse, which is AC over AB. So let's think of this quick. If we knew the two side lengths, well, we can find the third one. So let's say I knew the opposite and the adjacent side lengths. The Pythagorean theorem would give me the third side. So I now would know all three sides, which means I would know exactly what this ratio is equal to. So the tangent of A gave me that ratio. Well, the question now is, how do I undo the tangent of A? To get rid of the tangent, we take what's called the inverse, and we're going to use a special little notation today. All right, so see this little -1? That means inverse. And what we're going to do is we're going to take the inverse of the ratio that we know. So the inverse of BC over AB is equal to angle A. It's like and I'll show you when we actually do a problem, but we're getting rid of tangent and bringing it over to the other side. Now you're probably wondering, well, what is tangent inverse? All it is a button in your calculator. It's one extra button, and that's it. So how would I get rid of sine? Well, to get rid of a sine and move it over to this side, we do the sine inverse, which is the -1. And we do that of the ratio, that's the opposite over the hypotenuse. And if I apply that ratio, it will also give me angle A. And then for cosine, same thing. Take the cosine of AC over AB, that's the adjacent over hypotenuse. and it will give me A. I'm going to pause here and let you guys catch up. Okay. So for this example, we have to solve the right triangle, which means find all three sides and all three angles. And I encourage you guys to draw a box like this that just says, here are my three sides and here are my three angles. Now I did try to write this with intent, and I want to show you what I mean by that. So we know a couple of things, right? BC is 10, so I'm going to add that length in there. And we know AB is 22. Notice how that's the smallest side. So I wrote the smallest side first, and then I wrote the middle side. Middle, it's not technically middle, but I wrote the next side. And then the hypotenuse is the larger side. And then we know that angle B, which is the largest angle, so it should be across from the largest side, is 90. So that we know 3 of the 6 items we have to find, and that's always going to be true. You're either going to be given 2 sides and an angle, which will be 90, or you'll be given 2 angles, which will be 90 and another angle, and 1 side. And then we have to decide how do we find all the rest of the pieces of information. So then when you look at this, we have 2 sides. I can always find the third side by using Pythagorean theorem. And notice the third side is the hypotenuse. So I'm just going to do some real quick Pythagorean theorem here and find the length of AC. Nothing new here. Um, 22 squared is 484. And then we're going to take the square root of both sides. And our goal is to reduce this radical. Now there are multiple ways to do it. My goal is to take the largest perfect square that goes into this. So I might even model how I do that just to show you here. Let me see if I can get this working right. So I'm going to just take 584 and I'm going to divide it by the largest perfect square I can think of that might go into it. Now, I know that this probably isn't the case, but I'm just going to check. I always think of, well, 144, that's 12 squared. That doesn't go in evenly. So what about 11 squared? 121. Nope, that doesn't go in either. I know 100 isn't going to go in there, so I'm going to skip 100. And the next lowest would be 81. 9 squared. That doesn't work. So then I'm going to take and the next lowest, so 9 squared is 81. Well, 8 squared is 64. That doesn't work either. So then I'm going to go, the next one would be 7 squared, which is 49. That doesn't work. And then, let's see, 6 squared is 36. That doesn't work. And then, let's see, 6 squared, 5 squared. I know that 5 squared is 25. This number is not divisible by a 5 because it doesn't end in a 0 or 5. So I'm not even going to check 25, which means the next one will be 4 squared, which is 16. That doesn't work either. So then, let's see, 16, 3 squared is 9. That doesn't work. So then I've got, let's see, 2 squared is 4. Ooh, there we go. Kind of a long way to get there, but if I take and I divide by 4, I get 2 answers here. And then the square root of 4 we know is 2, and the square roots of 146 cannot be reduced down into any other perfect squares. Now notice, that's not a super friendly answer, right? Its decimal might even be better, but we don't like decimals. And if you're taking a test, we're looking for a reduced answer. All right, so that's the quick part, right? That's nothing new. What is new is how do I find angles? Let's focus on angle A. Right? Angle A is the angle I want to find. Now I know all three sides, so I could use any trig ratio. I could use the sine, or the cosine, or tangent. But in my mind, there's one better ratio to choose. And let's look at why. All right. Across from angle A is the opposite side. The side length, the leg that makes up angle A, is the adjacent side. And then across from the 90 is the hypotenuse. Well, look at how nasty the hypotenuse is. That's not very friendly. So I'm going to try to avoid using anything that has an h in it, which means to find angle A, I'm going to use tangent because that has the friendlier numbers. So what do? We're going to take the tangent of the angle. And that ratio has to equal opposite over adjacent. Well, we know what opposite is. Opposite is 10. Adjacent is 22. So technically, none of this is new right now. We just used the tangent ratio to set up. The only difference is I didn't know the angle measure A. All right, I want to show you one thing, and you don't technically need to write this step, but mathematically, I'm going to just show you what we're doing and why it works. So my goal is to get rid of tangent. Now, the A is inside of the tangent function. I cannot divide this. I'm not dividing by tangent because if I did, it would be dividing by tangent of what? The A is attached to the tangent. The only way to get rid of the tangent is to officially take what's called the inverse of both sides. And I know this looks kind of weird, but the tangent inverse is going to reduce out the tangent. That's like if I added and then subtracted, or I multiplied and then divided. These will undo each other, and the only thing that's left over is A. Now, once you realize this, you don't really need to show this step that I talked about here, but what are we actually doing? Well, in our calculator, we have to take the tangent inverse of the ratio of opposite over adjacent. And this is the new part right here. That little -1 is my inverse symbol. So all it is using your calculator. I'm going to let you guys get caught up to kind of what I have written, and then we'll show you how this works. Okay. Now, I just opened up a kind of a different program so you could see what my calculator looks like. I have to check my mode first. And we did this the other day, but if you're new to using your calculator, you're going to hit this mode button right here and then go down to radian and degrees. And since I'm trying to find the measure of the angle in degrees, I need to be in degrees mode. So I just scroll down and then scroll over to degree and hit enter. And that puts me in the right mode. You only have to do it once, so I believe all of us should be in the right mode. All right, so then I'm just going to go second, quit, and I go to a blank screen. So now the question is, how do I get this inverse function? Well, it's right above the original tan button. So you're going to have to hit second to activate the blue piece, which is tangent inverse. See that -1? That's our symbol for inverse. And then you're just going to type in 10 divided by 22, finish the parentheses, and hit enter. And there it is. That is the measure of the angle. And that's how quick it is to do this in our calculator. All right. Now, I always recommend that we're rounding to the third decimal. So this 9 is going to make the 3 round up to a 4. And then I like to put the degree symbol here as well. So your textbook, I believe, may round to the nearest tenth if you're checking answers in your textbook at all. We always say, unless the directions say round specifically, take it to 3 decimals. So what is that? That's angle A. 24.444 degrees. And if you want, you can always add that back to your picture. And then we just have one last thing to do. We have to find angle C. We have 2 options. I hope you pick the quick one. If you know 2 angles, can't you automatically find the third one? We don't need any special trigonometry. We only have to do inverse once to find the one missing angle, because now angle C, you have 2 options. You could add these 2 together and subtract from 180, and that would give you C. Or, since this is 90, I automatically know that angle A and angle C have to equal 90. So why not just take 90 minus angle A, and that will give me angle C. So if I do that, angle C is 65.556 degrees. All right. So what can we take away from this slide? The first thing is I can always find a side length using Pythagorean theorem if I know 2 sides of a right triangle. Inverse trig will always give me the measure of a missing angle. And once I do inverse trig once, I really only need to do it once, because then I know 2 angles. I can find the third using the triangle sum theorem. You could have done tangent of C the same way we did here, but change this to C, and then it would be 22/10, and you'd get the same answer. It doesn't matter if I find angle A or angle C first. All right. So first thing I like to do when I approach a problem like this is it says solve the right triangle. So I need to know all 3 sides, all 3 angles. I take the information that's given and I just record it down. So I know the side length AC is 15, and I might even identify that as the hypotenuse. And then I know angle B is 90 degrees, angle C is 57, and that means I can very quickly find angle A if I want. Angle A is just going to be 90 minus 57, and what is that, 33? So now all I have to do is find the 2 missing sides, and that's what regular SOHCAHTOA was all about, is finding missing sides given one of the acute angles. I'm going to use 57. You could use your answer of 33 as well, but I'm just going to focus on the angle they gave me. So what am I going to do? We've got across from the 55 is the opposite. We already know the hypotenuse, and then the angle that helps make up the 55 or 57 degree is the adjacent. Now you could call this X and Y, it doesn't matter. I'm going to go ahead and use the opposite and the hypotenuse. So if I'm thinking SOHCAHTOA, I want to find the opposite and I know the hypotenuse. So we're going to set up the sign of the angle measure, and this time we know the angle measure is 57 degrees. And then sine is equal to the opposite on top over the hypotenuse on bottom. And now we can make that a ratio equals a ratio. So we can cross multiply and solve very quickly. 1 times x is x. 15 times the sine of 57. And now it's just a calculator game. Take 15 times the sine of 57. So 15 times the sine of 57. I always recommend finishing the parenthesis. And there is our answer. So regular SOHCAHTOA in this one. Great question. Somebody just asked, what if we used the other angle? And I'll show you that in 1 second here. And then just round this answer to the third decimal. The 0 makes it stay as a 0, so 12.580. So what if we used angle A instead? Now notice, if I use angle A, this does not become the opposite, it's now the adjacent. And if I use the hypotenuse and the adjacent, don't write this part, but all it would be is cosine of 33 equals the adjacent, which was x, over the hypotenuse. So then it would be 15 times the cosine of 33. And I'll show you that really quick. So what is 15 times the cosine of 33? Exact same thing. So if you chose to use 33, as long as you labeled it differently, because my reference angle was C for the way I labeled it, if you labeled it where here's the opposite and the adjacent, you're going to get the exact same answer. All right, so it doesn't matter which acute angle you use. I always recommend using the one that they gave you. So that gave us x. And I like to plug that in. Now notice, so what is that? That's AB. That's 12.580. Then I just have to find the adjacent side. You could do Pythagorean theorem here if you wanted. Right? You have two sides. You could do Pythagorean theorem. I like to stick with trigonometry. And I'm going to stick with the fact that I'm going to use 57 degrees. And I like the 15 as my hypotenuse. And I want to find the adjacent. So I've got the hypotenuse and the adjacent, A and H. All right, so now I'm going to set up the cosine of 57 degrees is equal to the ratio of the adjacent, which is y, over the hypotenuse, which is 15. And then notice it's still the cross multiply, so 1 times y is equal to 15 times the cosine of 57. So hopefully you're pretty well practiced in that work. I'll just do 15 times the cosine of 57. And that gives me 8.1. Ooh, this is an interesting round. So I'm looking at the third decimal, which is a 9, but the 5 is going to round this up to a 10. So that's 1. So 0 and then put a 1. So I actually get 8.170. Okay. Now, I forgot to point this out with the last example, but there's a reason why I wrote my side lengths and my angles the way I did. I always write the smallest side first, and then what should be across from the smallest side is always the smallest angle. So look, 33 degrees and 8.17. That's the smallest side across from the smallest angle. And then the largest side is always across from the largest angle. And the medium, middle-ish side length is always across from like the middle-ish angle. If for some reason I got like 18 as an answer here, and as across from the smallest angle, I did something wrong in my work. So that's always something you could check. That relationship will always be true for every triangle. Okay, so instead of writing all this, let's read it and just draw our own picture, and then I'll have you go ahead and solve. So a soccer ball is placed 10 feet away from a goal. The goal is 8 feet high. You kick the ball so it hits the crossbar along the top of the goal. What is the angle of elevation that you kicked? So let's think of this. All right, here's your ball, and then here's the goal. Right, there's the soccer net. So what happens is you can think of this, and we know that this goal, its top height is 8 feet. And then I know that the ball is 10 feet away. Now notice, if it's a true accurate goal, then this is a 90-degree angle here. And our job is to figure out what is the angle of elevation of your kick. Well, what happens? You go and you kick the ball, and it's going to hit the top of the crossbar. So what this problem is asking you to find is what is the angle of elevation. Now think of angle of elevation referring to going up, right? The ball is on the ground. If you kick it straight, it would just go straight on the ground, but you had to kick it up with an angle of elevation. So we talked about that a while ago. So basically that's my goal, is I want to find out this angle. Now I'm going to just throw in this symbol, theta. That's our missing angle. All right. And if you want, you could erase the green part just to make it less confusing. But what do we have? Well, across from the angle theta is the opposite leg. The leg that makes up the angle theta is the adjacent. So I'm trying to find an angle. Whenever you're trying to find an angle, you use inverse trig. So, ka, toa. Well, let's see. What do I have? I have O and I have A. So I have to use the tangent ratio. And what do we know? Well, it has to be the tangent of the angle, so that's what I'm looking for, is equal to the ratio of the opposite over the adjacent. So once you have your information, you figure out your trig ratio and set it up the same way we've done last week, right? TOA is opposite over adjacent. But the only difference now is I don't know the angle measure, so I cannot cross multiply here because there's nothing to take the tangent of. So then all you have to do is say, I want the tangent to move over to the other side. And we're going to skip the step of doing tangent inverse of both sides and say, you know what? It's just a button in my calculator. It's the tangent inverse of 8 over 10. So if you have that, tangent inverse, 8 divided by 10, finish the parentheses, hit enter. And there's our answer. you need to kick the ball at a degree of 38 point, ooh, we got to be careful when we round, 660. And then I should indicate that that's degrees. That's the angle that this kick needs to lift up off the ground. So here's what we got tonight. Your homework tonight then is through Delta Math. It's titled Trigonometry Practice, Accelerated Geometry. I want you to submit a screenshot when you are all done. If you finish with this early, go ahead and work on any missing homework and get that stuff turned in so you're ready for our test next week.